Hello, viewers. You are very welcome to my channel. This is Hunters TV. Today, we are going to be looking at how to find the center of gravity of an L-shaped figure. Okay, or you can say how to find the centroid or center of gravity of an L-shaped figure. So let's look at this example. So we have example 1. Okay, says determine the center of gravity of the L-shaped figure below using the ratio method. Okay, so we are going to be using the ratio method. Okay, let's go. So let's analyze the question. Okay, as you can see, the base dimension of the figure is 100 millimeters. Okay, this side is 30 millimeters and the height is 90 millimeters. The upper dimension here is also 30 millimeters. Okay, this side is not given and this side is also not given, but you can still draw. Okay, bear in mind that in the examination hall, not all aspects, not all parts, or not all dimensions are going to be given to you. It is up to you to study the shape given to you and then deduce some aspect of the dimensions that are not given. Okay, so let's start. So to begin with, you have to draw the shape. You draw the shape to full size, okay, using the given dimensions. So let's start. Okay, so we draw this side first, the 100 millimeters base. So sorry for the disturbance. So this is the 100 millimeters base. Okay, then all right. Okay, and from the question, the height is also 90 millimeters from here to here, 90. So here is 100. Okay, let's measure our 90 here. So here is 90 millimeters, and then from the question, here is 30. You, with the help of your t-square on the drawing board, you use your t-square, and then your 30 degrees set square or your 45 degrees set square, your t-square horizontally and your set square on. Okay, you draw your vertical side. Okay, it's already there. So you measure your 30 millimeters. Okay, so this is my 30. Okay, let's draw this side. Okay, from here to here is also 30 millimeters. Okay. To just go from here to here. Okay. Okay. You clean all excess lines like this. Good. So you get your L shape. Good. Can write here 30 millimeters. Here is also 30 millimeters. Okay. Now, the next step, we are going to find the area of this shape. Okay, this L shape. But you can see it is not going to be easy. It's not possible to find the area of this shape. Okay, because it's a complex shape. So the first thing we do is to divide this into two rectangles. Okay, yes, so you can easily find the area of the two rectangles and then you add. Okay, so you can prolong this line or you can extend this line here vertically so that we get two rectangles A and B. Okay, or you can extend this line horizontally. Okay, so let me do this. So let me extend this here. Okay, so now we have rectangles A and B. Okay, next step, draw the diagonals of these two rectangles. Okay, draw the diagonals. So this cork is disturbing me. Okay, let's go. All right. So where the two diagonals meet, you can name the C1, center 1, C2, center 2. Okay. Right. Next step, we are going to find the area of the two rectangles. So let's find the area of rectangle A separately. Sorry, and then area of rectangle B also separately. So you say area of A, as you know, area is given by length times breadth. Okay, so for A, the length is, you see, it was this side from here to here 90 millimeters, but for A alone is the length will be from here to here, and we know from here to here to be 30. Okay, you can trace it from here. So 90 minus 30, so it means the distance here is 60. Okay, 60 millimeters. Good. So it's 60 millimeters by 30 millimeters, and the area will give you 1800 when you multiply square meters, sorry, square millimeters or millimeter square. Okay, let's go to area of B. Area is equal to length times breadth, which is equal to, for B, the length is 100 millimeters and the breadth is 30. Okay, so area will give you 3000 millimeters square. Good. Now, after getting the areas or the area of the two rectangles, you find the ratio of the areas in the simplest form. Okay, so you express this and this as ratios. Okay, in the simplest form. So we write ratio of A is to B. Ratio of A is to B. For A, we had an area of 1800. Okay, is to B, we had 3000 millimeters. Okay, like this. Okay, then we have to simplify or break the two ratios, break them down to the simplest form. Okay, so this 0 will cancel this 0. This also cancel this. We have 18 is to 30. Okay, then you break it down. You ask yourself which number can divide the two numbers without any remainder. Okay, so 6 can do it. Okay, 6 goes into 18. 6 3 18. Yeah, so 6 goes into 18 3 times, and then 6 also goes into 30 5. 6 5 30. Okay, 5 times. Okay, so the least ratio or the final ratio, the smallest ratio, is 3 is to 5, where 3 corresponds to A and then 5 corresponds to B. Okay, let's go. Next step, find the sum of the ratios. So you add the two ratios. Okay, let's add. So sum of ratio. Please, in the examination hall, don't do all these calculations on your drawing sheet. You can do it on the question paper. Okay, it's a rough work. Okay, so it's 3 plus 5, which gives you 8. Okay, 8. Next step, after getting the 8, join centers, join C1 to C2, join this to this. Okay, join this to this. Use a faint line. I'm using this. Draw a line to connect center 1 and center 2. Then you divide this line, divide line C1, C2, divide this line into 8 equal parts. Okay, that's the sum of ratios. You are going to divide this line using the division of line method. Yeah. How do you do it? Okay, so draw a line, not too wide, like an acute angle. Yeah, faint line. Okay, draw a faint line. Yeah, and you take your compass, you open to a suitable radius. You check the distance you're going to be dividing. Okay, then you open your compass according to the space you're going to divide. It shouldn't be too wide, it shouldn't be too small. So use a suitable radius. Okay. So I'm going to divide it into 8 equal parts. Okay, so we're going to use this distance. Okay, start from C1, start from center 1, you step off. Let me open it a bit. You step off 8 times, you mark along the line 2, 3, 4, okay, 5. This place is very noisy. Pardon me. 5. So let's see. Let's see. 1, 2, 3, 4, 5, 6, 7. One more. 8. Okay. 8. So this is the final point. You know what to do. You join the last point, the 8th mark, to C2. Okay. You join this to this. What do you do next? You are going to draw power lines. Okay. You set your set square, either 45 degrees set square or the 30 degrees set square. You set it, you place it exactly on the line, the last mark that you draw. This one. Okay. Let me use this longer one. Okay. Set it like this. Press it firmly. Okay. So just slide it. Make sure it doesn't pass under it. Okay. So just slide it. You slide it gently to the marked points, and then you transfer them like this. Draw power lines. Okay, so we have 8 points. So with this, we have been able to divide center or line C1, C2 into 8 equal parts. Okay, 8 equal parts. So let's see. There is 1, 2, 3, 4, 5, 6, 7, and 8. Okay. Final step. After getting this, you are going to locate. The question says determine. Okay. You're going to determine your center of gravity, or the centroid. Okay. Now, what is the centroid? You see, it is the point. Okay, a point which, after placing this L shape on, okay, it will keep the shape balanced, or it will be in a state of equilibrium. Okay, like something like this. Assume it is the center of gravity. Okay, the center of gravity, or the centroid. Then, if I place this shape, this ruler being the shape, if I place it on it like this, okay, it should be balanced. It shouldn't tilt to the left or the right. It shouldn't fall. It should be able to be stable. Okay, that is the center of gravity. Now, the final ratio we had 3:5, where 3 correspond to A and then 5 correspond to B. So it means that under normal circumstance, we are going to be counting 3 units or 3 steps from center 1. That's from A. So we'll be counting 1, 2, 3. No. Okay. But if you do that, the shape will not be balanced, okay, on the center of gravity. So this is what we do. We swap it. We swap the figures or the numbers like this. So the ratio for A becomes that of B, and the B also becomes that of A. You swap it, okay? So instead of counting 3 from A, 3 units, 1, 2, 3, okay, to get the center of gravity, we swap it. So the 5 comes first, okay? You swap it. So we are going to count 5 units, okay? 5 units from A, and then 3 units will be from B. Okay, so let's go. 1, 2, 3, 4, 5. 5 here. Okay. Here. This side will be the center of gravity of the ship. Okay. So 5 units. 1, 2, 3, 4, 5. From A, then the B. 1, 2, 3. So at this point, so let me name it. So this is the centroid. There is the centroid here. So at this point, this is the point. If you are to balance, or if you are to place this L shape on this point, okay, it will keep the shape balanced, or it will be in a state of equilibrium. Okay, that is all. That is how we find the center of gravity of an L shape. Okay, thanks so much for watching. We are going to be solving more questions, okay, on center of gravity and other related topics. Okay, don't forget to click on the subscription button, and also like the video, share, and invite your friends to also come here and also learn. Thank you so much. See you.